So this is the calculator section of your practice exams. These are questions where you might need the support of a calculator. You might not. It's kind of with these questions, maybe you'll need the calculator, maybe you won't, but it's there as support if you need it. So what we're going to do first is simplify expressions. So in the no calculator part, we looked at solving equations where you ended up with x equals some number. With expressions, you do not have an equal sign. Oops, I wanted to write that down. No equal sign. There is a way to kind of use it, but basically with these, you should not end up with x equals some number. All we're doing here is combining things if we can. If there's a way to combine like terms, we want to do that. But that's about it. We won't end up with a single solution. So with these, you can go through the work without ever writing an equal sign. So I'll try to do that I will do that with all of these so that we don't get confused between these two types of problems, solving equations versus simplifying expressions. So with this first one, it's all numbers. I do want to see your work with these. So what we're going to do is simplify. This is all addition, subtraction. So what we're going to do is you just work left to right. So we'll combine that -8 plus 4 first. So that's a -4. And this plus -7, you could leave it like that, or that does translate to a -7. Whichever makes more sense to you in simplifying, you can use it. -4 minus 7 is a -11, and then plus 3. And then combining those two, that would leave us with a -8. Now, with this one, since it's just a bunch of numbers, type it into the calculator. Type in that -8 plus 4 plus a -7 plus 3, and you should get out that -8. So there is a way to check your solution with this one. All right, with part B, we're adding fractions here. So what we want to do is we need common denominators. So if we think about the least common denominator between these two, so a number that they can both multiply up to, I think 40 is going to be our least common denominator here. So what we want to do is adjust this -1/5, adjust this 3/8 so that they have the same denominator. So with the 5, we need to multiply by 8 to get 40, and then whatever we do to the denominator, we need to do to the numerator. And then the 3/8, we need to multiply that denominator by 5, which means we need to multiply that numerator by 5. So what this ends up being is -8 over 40 plus 3 times 5 is 15 over 40. Then combining our fractions, we'll have -8 plus 15 in the numerator over 40. And then simplifying that down, the 15 minus 8 is going to be a +7 over 40. And then we just want to see if that simplifies down, but doesn't. And type this into the calculator, see if you get the same value out. All right, here we have division with fractions. So what we want to use is that rule, keep, change, flip. Or there's so many different variations of that rule. But what we're going to do is keep the first fraction, change our symbol to multiplication, and flip the fraction. Now the negative just stays negative, so I'll still have our negative symbol, but the numerator, denominator flips. So simplifying this down, negative times negative is positive, so we can kind of just ignore those negative symbols because they're going to cancel each other out. And in the numerator, we'll have a 3 times 5. In the denominator, we'll have a 5 times 4. At this point, you could simplify down. You could see that those 5s will cancel out with each other, or you can multiply it out and then just notice that you have to reduce, but you should end up at a final solution of +3/4. All right, with part D here, now we have some variables in here, which means we'll most likely have variables in our solution, but we're not solving for the variables. Again, you won't end up with x equals a single number here. We're just making this equation simpler. So what we have here is this minus and then parentheses. So it's like there's this -1 that needs to distribute in. So we're going to distribute this negative so that we'll have this 5x, and then it's like a -1 times 3x. So that's a minus 3x, and then -1 times -8, which is a positive 8. And then once we get rid of our parentheses, what we want to do is look for like terms, which that 5x and minus 3x are like terms. So this would be 2x plus 8. All right. Now with this one, we have many different layers to our parentheses. With these brackets, these are just kind of outside parentheses. So what we want to do is simplify inside. So what we're going to start with is let's go ahead and distribute that 5 and just start simplifying what's inside the brackets there. So we have 3 and then bracket 5 times y, 5 times -3, and then plus 9, and then close that, plus, and then we could go ahead and distribute over here, it's a separate term, 2 times y, plus 2 times 8. And then with the brackets, we need to simplify a little bit further. We have these like terms that we could combine. So we still have 3, we have that 5y, but -15 plus 9 should be a -6. And then we have this plus 2y plus 16 still hanging out that we can't really do anything with. So then what we'll do is distribute the 3. So 3 times 5y, 3 times -6, plus 2y plus 16. And now that the parentheses are gone, we can start combining like terms. So we have this 15y plus 2y that we could combine. So that'll make 17y. Then we have this -18 plus 16, and that'll be a -2. And then that's stuck. There's nothing else to simplify. That would be our final solution. All right, then with this last one, we have 2 variables. But a lot of the work will be similar to what we were doing. So to get rid of those parentheses, we need to distribute the 4. So 4 times 2a is 8a. 4 times -3b, -12b. And then we have a plus a minus 7. Now for like terms, it has to be the same variable. So what we'll have is this 8a plus a. We can combine those, but then there aren't any other like terms. So 8a plus a is 9a, and then we'll have this minus 12b, and then minus 7. All right, so that's simplifying expressions. Again, if you have variables, you'll likely end up with an expression at the end. If you have just a string of numbers, you'll end up with a single number solution. But again, no equal sign should be showing up in your work there. What I was saying before with how there is a way to see equal sign is if you were writing equality through the simplifying process, saying like this first expression is equal to this next one is equal to that next one. But it's not necessary. Some schools like it for formatting, but you can avoid equal sign completely with these. All right, finding linear equations. So what we want to do is fit our y equals mx plus b form. And there's different ways that we can find this equation. It just depends on what information we're given. So here we're given the y-intercept of -3. So that's telling us exactly what b is, and a slope of 3/4, which is exactly what m is. So with this first one, all we have to do is plug in the numbers. So 3/4 for m, and that'll multiply with x, and then b is -3. And that would be our equation. Probably the most common mistake with these, especially when it's kind of simple like this of just replacing variables, don't forget x. It is very important to have your variable x in there. Just a common thing that can happen with these is just writing like 3/4 minus 3 because you're just plugging in, but x has to be in there. All right, the line has a y-intercept of 2 and goes through the point 5, -1. So there's a few different ways to do these. this is giving us what b is. So what we do have is we have kind of the start to our equation. We have an mx, and then for b we have this positive 2. Then from here there's two directions. What you could do is plug in the coordinate 5, negative 1 and solve for x. Or what we could use is the fact that we have these two coordinates, like this is the coordinate 0, positive 2, and then you have the second coordinate of 5, negative 1, and with that you can use the formula for slope. Let's go ahead and use that for this equation. So we'll use, here's x1, y1, here's x2, y2, and then we'll use our formula for slope. So y2 is negative 1 minus y1 is positive 2 over x2 is 5 and minus 0. And if you're worried about order with these, something I do is think about how vertically it's your coordinates. So here's my coordinate 5, negative 1, here's my coordinate 0, positive 2, and the subtraction is just part of the structure. So just make sure your coordinates are lining up with y is on top and x is on bottom. All right, so simplifying this down, negative 1 minus 2 is a negative 3 over 5 minus 0, and there's our slope. So what we'll have here is y equals negative 3/5 x plus 2. Now, the other way you could have done this problem is if you have that y equals mx plus 2, you could just plug in that coordinate 5, negative 1. So y is negative 1. We don't know what m is, but we know x is 5. And then solving for m. So we could subtract 2 from both sides. That'll be negative 3 equals 5m. Divide by 5. And that would also give you your slope. So either way with that question, you get to the same solution. All right, this one where you're given two coordinates and neither is an intercept, what you want to do first, there are specific steps that we would need to follow. First thing we need to do is find our slope. That'll be the easiest to find. So here we'll have to use our formula. So x1, y1, x2, y2, and slope is going to be taking that 8 minus negative 2 over 4 minus negative 3. So let's see, we'll have an 8 plus 2 over 4 plus 3. So slope here is 10/7. So then what that does is it gives us a structure. So what we can do is plug it in so that we can see we have y equals 10/7 x plus b. So then we can see the structure, and then what we'd want to do in our next step is plug in 1 point and solve for b. So what that would look like, and you can use either coordinate, both will give you the same solution. I'm going to go with 4, 8. My only inclination to use that number is to solve positive numbers, and positive numbers just tend to be easier to handle. But again, it doesn't matter. So what this will look like, and I'll actually move this up here, is y is 8 equals 10/7 times, and x is 4, and then plus b. And then what we're going to do is solve for b. So we'll have 8 equals, and this is 10/7 times 4 over 1. So 10 times 4 is 40 over 7 plus b. And then we'll want to subtract that 47ths from both sides. So solving for b, we have this 8 minus 47ths. And then to combine those, if we're showing our work, or you could just, this is the calculator section. If you just want to use the calculator, that's fine, but it doesn't hurt to see more fractions. This is our 8 over 1, so we need a denominator of 7. So you'd multiply both by 7. So you'd end up with this is 56 over 7 minus 47ths. So this will reduce down to 16/7. Sorry, just checking my work real quick. All right. So our final equation is going to be y equals 10/7 x plus 16/7. All right, so that's how we can find our equations, kind of given different pieces of information. All right, solving inequalities. So just like with solving equations, you should end up with a final solution. It's just going to be an inequality symbol between the number and our variable. So what you should end up with here is kind of x, and then a symbol, and then number. Now our only rule we have to be careful of here is when we divide or multiply by a negative number, we flip the symbol. All right, so this first one, to isolate x, we'll want to subtract 6 from both sides. So that'll leave us with x less than or equal to -4. And that's done. In terms of checking solutions here, you could plug in, you would just choose a number that's less than or equal to -4 and make sure that it works. With part B, we would move our variables to one side, so subtract 13x from both sides. So that'll leave us with just an x plus 9 is more than -4. Then we could subtract 9 from both sides. So x needs to be more than -4 minus 9, -13. 12x is less than or equal to 60. We need to divide both sides by 12. So that'll leave us with x less than or equal to 5. And since we divided by a positive number, our symbol doesn't change. All right, here we need to divide by -2. So here's the special case where we're dividing by a negative number. So whatever your symbol is originally, we're flipping the direction of it. And then everything else operates as it usually would. So like we'll just have y to the left-hand side. And then 26 divided by -2 is a -13. All right, with this one, we'll divide both sides by, well, there's two ways to go about this one. Let's actually get rid of the denominator first, just to avoid fractions, because I know most of us probably want to do that. So what that would entail is multiplying both sides by +4, so that on this left-hand side, we'll have this -20x, and then more than or equal to, and then on this right-hand side, the 4's would cancel, so all we would have left over is a 1. And now we don't need to worry about fractions at all. Then we'll divide by -20, and we're dividing by a negative number, so our symbol needs to flip. So on the left-hand side, we'll just have x, and then on the right-hand side, we'll have this fraction of -1/20. All right, and then with this one, we can subtract 5x from both sides. So we'll have a 5 minus 14x more than or equal to 19. Subtract 5 from both sides to get x all alone. So we'll have a -14x more than or equal to -14. And then divide by -14, divide by -14, and we divided by a negative number, so the symbol needs to flip, and then we'll have x is less than or equal to +1. And that's solving inequalities. All right, some word problems. So we talked about these percent increase problems, and as an account builds, how can we look at past values? So let's use the symbol A to represent the original investment. So what we know is that after 1 year, we have $924 in our account. And what that came from was having our original investment and then adding 5% of that value. So that like if we had $100 in the account, we added $5 to it and we ended up with $105. So with this, we can see how the account would build, and then we have this value that we ended up with. Now to simplify, Combining our variable, again with that first value of a, it's like there's this coefficient of 1. So combining our like terms, we're taking this 1 plus 0.05. So it's a 1.05 times a. And then we'll just divide both sides by 1.05. And we'll get a is 880. So the original investment was $880. If this was decreasing, the only change you would see is subtraction. So then we'd have like a 0.95a in the next step. That's really the difference you'll see. All right, an equation that's described as this linear scenario. So some key wording here is they give us information about how the price is decreasing by $250 per month. So we have this rate of decreasing, and it's a value that's going to happen over and over. So as each month passes, we're bringing the cost or the value down by $250. So this description is getting at the idea of slope. And what that slope's going to be is this negative 250. Since it's decreasing, we're taking away 250 each month. Then the other piece is this base value of $20,000. So that's like our starting value, and that's always going to be our y-intercept. So we're going to have this y-intercept of $20,000, so that when we plug in like 0 months, we'll have this value of 20,000. And then as months pass, we're taking 250 away from it each month. So in terms of an equation, to have the value of the car, we'll have this slope of negative 250 per month, and then with a y-intercept of 20,000. Again, if you're not sure about your equation, think about making a little table or even just plugging into the calculator. Like, what would happen if you plugged in 0, 1, 2? Is it operating how it matches the wording of the description? All right, and then using our equation to determine the value of the car after 1 year. Now be careful that we don't want to plug in 1 to the equation, because this is in terms of months. So what we want to use is the fact that 1 year is the same thing as 12 months. So to find the value, what we'll do is plug in 12. And if we just throw that into the calculator, that'll give us a 17,000. So the value of the car after 1 year is $17,000. So with these equations, look for that rate of change and that starting value, and that'll fit your equation for the slope-intercept equation of the line. And that does it for our practice final.